Welcome to Chemistry at Hononegah High School. I'm Brian Brown, and today we'll be looking at our second set of notes from Chapter 3, which really gets into how do we make measurements. But before we look at making measurements, we need to have a better understanding of a couple of words that often before chemistry many students think are the exact same thing, which would be accuracy and precision, because there's going to be times throughout this chapter and all year I'm going to be talking about these two things, especially when we're looking at labs and measurements, and you need to make sure you understand them much better than you probably do now. Now, accuracy you probably do already know. Accuracy is how close a measurement is to its true value. In other words, if we knew exactly what its measurement was, how close are we to that actual value? That's how accurate something is. Accuracy is a comparison of one substance to what it's supposed to be. Now, precision, which a lot of times at the beginning people confuse with accuracy, is actually something entirely different. It's still important in terms of understanding measurements and making good measurements, but it's not about accuracy. Precision is how close a group of measurements are to each other. So notice it has nothing to do with being accurate or being correct. It's just when I make a measurement, do I get essentially the same thing every single time I do it? That would be precision. A good way to test your knowledge of these two is to look at a situation where I'm shooting some arrows at a target. Now, obviously, when I'm shooting arrows at the target, my goal is to hit the bullseye. So let's say I shoot one arrow and I hit the bullseye dead on. I would say that one shot was very, very accurate. But what can I say about its precision? Absolutely nothing, because I don't have any other arrows to compare it to. Remember, precision has nothing to do with whether it was a good shot or not. It's how close your shots are to each other. So, second situation here, I shoot 3 arrows. Now, all of the arrows are close together, so that's high precision. But none of them are at the bullseye. So they're all away from the bullseye. So none of them were accurate. So individually, the 3 shots were inaccurate, but as a group, they were precise. Now next I shoot 3 arrows and they all hit the bullseye. My grouping is close together, so that's high precision. And I hit individually each time exactly what I was trying to do. So they all 3 were accurate. Now the last one, I'm all over the place. I totally missed the bullseye each time, and they're all spaced far apart. So none of the 3 shots were accurate. And as a group, I was very imprecise. My shots were not close together. So accuracy and precision are both important for measurements. We want to be able to measure accurately, and we want to be able to measure reproducibly. Do the same thing over and over again. Both have validity and importance in making measurements. Now, how do you actually make a measurement? Well, honestly, before chemistry, you probably haven't been shown how to really use a device to its maximum potential. And that's really what we want you to do. We want you to use a measuring device, whether it's a graduated cylinder or a thermometer or a centimeter ruler. We want to use it properly and get the best measurement we can. Be accurate, but get as much precision as possible with it. So the measurement rule is you should be able to estimate to 1 decimal place more than the smallest division of the device. Now, that's a mouthful, so really what do those words mean? Well, when you pick up a measuring device, the first thing you need to do is look at on that measuring device, what are the smallest divisions within the device? And we're going to then use those smallest divisions to make a more accurate measurement. So let me skip forward here a second. Let's actually look at a ruler. So when I glance at this ruler, I see it says 1 and 2 and 3, and those would represent centimeters. That's why you call it a centimeter ruler, because the numbers on the centimeter ruler represent centimeters. Now, when I look at them, what part of a centimeter is the smaller divisions? Because I've got divisions smaller than a centimeter here. That's what I mean by finding the smallest division. Now, a quick, easy way to do that, to find the smallest division, if you can't look at it intuitively see, oh, that's going to be tenths, or that's going to be hundreds, or that's going to be ones or tens. Good strategy is take a look at 2 numbers and subtract the difference between the 2 numbers, and then count how many divisions are spaced between those 2 numbers, and divide that into your answer. So we go back to our ruler here. I see that I'm going to pick these 2 numbers right here. So the difference between 2 and 1, 2 minus 1, that's going to equal 1. Now count my divisions. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now notice I didn't count the lines. I counted the actual divisions, because there's only 9 lines, but there are 10 divisions in between. So I'm going to take 1 and I'm going to divide by 10. So my smallest division here would be the 10th of a centimeter. Now the measurement rule says I can go to 1 decimal place better than the smallest division. So If my ruler reads to the nearest tenth, which would be, something, point something, that's the tenths place, then I should be able to estimate to one decimal place better, which would be the hundredths place. So I should be able to always use this centimeter ruler to go to two decimal places. So something like 1.24, that would be a valid measurement. It would be as precise, and I'm maximizing my potential of this measuring device if I used it in that way. So to jump back a second, what types of things are we going to be measuring with, and what are the typical units? Well, these are the three big that you should know. Graduated cylinders, we use milliliters every single time. So whenever you're using a graduated cylinder, it's always going to be in units of milliliters. And this is something you got to know for the test, because you'll see a picture of a graduated cylinder with liquid in it, and you're going to need to measure it. Well, you need to know your unit is going to be milliliters, because you're not going to see that listed anywhere. Next, thermometers, we always use Celsius thermometers. And then with a ruler, we always use centimeter rulers. So we're going to be measuring in centimeters. So remember, whenever you have any of these measuring devices, those are always the units you're going to be using. Now, we also use balances, but the nice thing about balances, it does the measurement for us. So we're just going to copy down all the numbers, but we would use units of grams for a balance. So remember, when we're using this type of device, we need to know what is each of these smallest divisions, which in this particular case is going to be the tenths. And if it reads to a tenth of a centimeter, then we can visually by eye break this distance into 10 equal places and make a valid estimate. And that's really the key here, is we're trying to end up with a better, more precise, more reproducible, closer to everybody else's number. And we can do better than going to the nearest hash mark, which is probably what you used before. So if I was measuring where that arrow was at, before you'd probably say, well, that looks like it's about 2.1, 2, 3, 4, 5, 6, 7. That's pretty close to the 2.7. I'm going to go 2.7. But you can do better than that. It's clearly past 2.7, but not quite to the 2.8. So we can make a better measurement if we're using the device properly. And your first job is to find out what is the smallest division. Is that the tens, the ones, the tenths, or the hundredths? It's usually going to be one of those four. And then we can do to one decimal place better than that. So ones, we could go to the tenths, tenths, we could go to the hundredths, and so on. Now, every measurement is going to require us then to make an estimate, because the device only does so much work, and then we're going to have to finish and do the work. Now, the estimation depends upon the number of divisions in the device. So what are we going to estimate to? Which place, which decimal place? It really depends upon that smallest division. So in this case, because this is another centimeter ruler, and it's a lot like the last one. It looks different, but we have numbers 1, 2, and in between we have 10 divisions. Each division on this ruler is a tenth of a centimeter. Well, if we can then read certainly to the nearest tenths, that means we can estimate to the nearest hundredths. So if we're going to measure with this centimeter ruler this bar, we know that it's at least 1.7. I mean, we're not unsure of that. Every single person who's using this device accurately, that is, would say, yes, it's definitely more than 1.7, but it's not 1.8. So everybody would say with certainty that the 1.7 we could all agree on. Now, you can see it's actually slightly longer than 1.7. So we can do better than saying, well, it's approximately 1.7 centimeters. If we want to be as precise as possible and still maintain accuracy, we can go to the hundredths place. So clearly it's between the 1.7 and the 1.8. And we're uncertain exactly where it is because we don't have an exact measurement in between. There's no lines in between. So what we have to do is we have to estimate. Now, your eyes are good enough to mentally divide a space into 10 equal parts, but that's it. You can't go better than that. So you can't divide things into 100 equal places and try and come up with a valid measurement. But you can make a rough estimate that is going to be valid if you divide into 10 places. So what you're going to be doing is estimating, and it's going to be a valid part of the measurement, but it's not going to be certain. Not everybody's going to get the exact same number here. So when we use this device, we should be making an estimate as to how many hundredths we think this is. So take a look at it and see. First, are you exactly half or more or less than half? And then start to differentiate between a lot more or a lot less than half. And that will help you make that estimate. Now, in this particular case, it looks to me like it's about halfway in between the two lines. So I might say that this measurement was 1.75 centimeters. Now, somebody else may look at it and say, no, I think it's just under. It's 1.74. And somebody else may say, well, it's just passed, it's 1.76. You need to realize all are valid measurements. We all had 1.7, and it's definitely between 1.7 and 1.8. So we were all accurate. But our estimates had a very small variance to them. Well, think about it. If we're estimating to the hundredths, we're going to differ by a hundredth. If we estimated to the tenths, and somebody said, I think it's closer to 1.7 and wrote 1.7, or I think it's closer to 1.8 and wrote 1.8, they're going to differ by 10 times as much as that. They're going to differ by a full tenth. So this is about being as precise as possible, getting reproducible numbers, numbers that are going to be closer together than 1.7 and 1.8. So remember, you're not going to necessarily agree with your neighbor, but you're going to be very, very, very close to them if you're using that measurement device properly. So you always go to one decimal place better than the smallest division. Now, remember that last decimal place is uncertain. So when we make measurements, we actually have uncertainty in our measurements. And since in this case we were uncertain in the hundredths place, we would basically say it's, like 1.75 plus or minus 0.01, 0.02, somewhere in there. Most of the time, people will say, okay, what's the true value? Well, I thought it was dead weight in between, so I'm going to say 1.75. And pretty much everybody in this class, if you're measuring properly, should be able to come within 1/100th of that. So that estimated digit is going to have some slight variance or uncertainty to it. But that's okay because it's a very, very small uncertainty compared to the 1.7, 1.8. So if we use the measurement device properly, we're not only accurate, we're as precise as we're entitled to. And when we eventually get into the math with measurements, you'll see that makes a difference, being as precise as possible. So I want you to practice it here. So why don't you just stop and pause the tape here. So pause my voice, and I want you to go through and try and make valid measurements with these three measurement devices. So where are these arrows at in each case? So go ahead and pause and make your measurement. Remember, the key is how many decimal places I'm going to record to. So what's the smallest division, and then go to one decimal place better than that on your estimates. So go ahead and pause and do it. All right, now that you've made your measurements, let's go through and take a look at what I thought the measurements were. Well, the first one to me, well, the smallest division is the tenth, so I'm going to estimate to the hundredths. So whenever I use this ruler, I'm going to hundredths, two decimal places. Now, it's definitely 1.9, and to me it looks like it's a little bit under halfway. So I said 1.94. But remember, 1.93 to 1.95, all of those are valid. As long as you had two decimal places, and you had the 3, the 4, or the 5, you were making an accurate and precise measurement. Now, in the second situation, now it looks like it's dead on the 3. So a lot of people want to write 3. Or they think, well, wait a second, he was talking about getting more decimal places, so I'm going to write 3.0. But the reality is, this is the same ruler as the one above. And if before I could measure to two decimal places, I could estimate to the hundredths, I should be able to estimate to the hundredths here. And what that would mean is I'm going to have to write 2 zeros. So it's going to be 3.00 centimeters. That would be the best measurement that I could make here. Now, if you said it was just under 2.99, just over 3.01, I wouldn't argue with you because I think it's a valid measurement. You went to two decimal places too, so you were using the measuring device properly. Now, this bottom ruler is not the same as the two above it. So in this particular case, our smallest division was 1 centimeter. So if it reads to the nearest 1, that means, and it might help if you see kind of our idea here. So left and to the right of the decimal, you've got the tens place and the ones place and the tenths and the hundredths. So if it reads to the nearest ones, which is there, then that means I should be estimating to the tenths. So this one, I can only go to one decimal place. Now, when I look at it, it's definitely between 1 and 2. And I might say at 1.4, 1.5, somewhere in there. Well, to me, it was pretty close to the half, so I went with 1.5. But somebody else might say 1.4 or 1.6, and even 1.3, 1.7 is close enough, I'd probably say that's a valid measurement, because after all, you were more precise and went to the tenths, which is what you should be doing with a ruler that looks like this. So those are rulers. Another common measuring device is a graduated cylinder. Now, graduated cylinders are special because they have this dip called the meniscus, which you may have heard of in middle school. So we use it to measure liquids, and they have this little dip, which makes reading them a little bit trickier. Remember, you need to read from the very bottom of the dip, and that's actually how this graduated cylinder was designed. It was designed to read when you put water in there from the very, very smallest bottom of the meniscus. So in this particular case, when I use this device, since I've got a number 21 and 22, the difference between them is 1 milliliter. And I've got 10 divisions, so that means this device reads to the tenths. Well, if it reads to the tenths, I should be able to estimate to the hundredths. So if you put a dotted line at the bottom of that meniscus, you can see that it's definitely more than 21.1, definitely less than 21.2, and to me it looks like it's pretty close to halfway in between. So about 21.15 would be a valid measurement. And like I said before, there's going to be variance here. Somebody else might say 21.14 or 21.16, but we're all going to be pretty close to each other. They're all valid measurements. But yes, with a graduated cylinder, it's a little bit trickier. So let's practice a couple of them here. So I've got the graduated cylinder on the left. Go through and do the same thing. Pause a second and figure out what you got. Okay, one on the left, it's definitely more than 20.6, but not 20.7. So about 20.63 would be a pretty accurate guess. Top one, it's definitely right at that 21.8. But since I can estimate to the hundredths, that means 0 hundredths. So I'm going to put 21.80. And remember, there's some slight uncertainty to these numbers. That last digit is an estimate, so it's going to be some slight variance. But we will still get very close together if we're using the device properly. Now, here's some that look like real graduated cylinders a little bit more. And you don't have any dotted line. So look at these 3 cylinders and make your estimates here. So pause the tape and make your estimates. Remember, the key is how many decimal places will it read to? And then I go to one more decimal place than that smallest division. Okay, first one, graduated cylinder number 1. Well, it says a 5 and a 6, and there's 10 divisions in between, so we're back to tenths again. So this reads to the nearest tenths, which means I can estimate to the hundredth. So I should be going to 2 decimal places whenever I use this graduated cylinder. Now I look at the very, very, very bottom of the dip. Now it is between the 0.7 and the 0.8, but it's lower than halfway. So it's not going to be 5.75. It's going to be smaller than that. And I thought it was a little bit lower than just right next to half. So my guess was 5.73. But anywhere 5.72 to 5.74, using the device correctly, very close together, all accurate. But the bottom of the dip is below the half. So I would have said 5.75 is off on this measurement. Now go to the second one. The second one, the smallest division is nearest 1, so we can estimate to tenths. Right on the 3, so that means I'm certain it's a 3, and I'm guessing it has 0 tenths, so 3.0 milliliters. Now you might have thought, although this close you probably wouldn't have, that it could have been a 2.9 or maybe a 3.1. In the real world, it's a little bit trickier than what you see here. So those would all be valid measurements because they went to the tenths as well. Now the last one, the third graduated cylinder here, since it read to the tenths, that means we can estimate to the hundredths. And this one did look pretty close to me to be about halfway in between. But 0.34, 0.36, I can't split hairs. Those are both valid measurements as well. And that ends our second set of notes where we're looking at really how do we use measuring devices in the real world in chemistry.